Right now, at this very second, two human-made objects are sailing through interstellar space, and most people have no idea they exist. But here's what'll blow your mind. They're carrying a golden record with instructions on how to find Earth. Wait, did we just give aliens directions to our home? We'll get to that controversy in a moment. But first, let me tell you why this changes everything you think you know about exploring beyond our solar system. In 1977, NASA launched Voyager 1 and Voyager 2, and as of 2024, Voyager 1 is over 15 billion miles from Earth, officially in interstellar space since 2012. That's the farthest any human object has ever traveled. Sounds impressive, right? Well, here's the reality check. At its current speed of 38,000 miles per hour, Voyager 1 would take 75,000 years to reach the nearest star system, Proxima Centauri, which is just 4.24 light-years away. And that's our closest neighbor. The Milky Way galaxy alone is 100,000 light-years across, and there are an estimated 2 trillion galaxies in the observable universe. We're not just talking about a road trip here. We're talking about distances so vast they mock our current technology. But before you think humanity is stuck in our cosmic neighborhood forever, let me share something that happened in 2016 that changed the game. Breakthrough Starshot, funded with $100 million by billionaire Yuri Milner and backed by Stephen Hawking, announced plans to send tiny spacecraft called Starships to Alpha Centauri. These aren't your typical spacecraft. We're talking about gram-scale probes attached to light sails, propelled by powerful ground-based lasers to 20% the speed of light. That means a journey to our nearest star system in just 20 years, not 75,000. The project aims to launch these probes within this century, possibly by 2050. Now here's where it gets controversial. Some scientists argue we're wasting resources on interstellar dreams when we haven't even properly explored our own solar system. Mars missions cost billions, and we're talking about technology that doesn't fully exist yet for interstellar travel. Critics say fix Earth first, explore our oceans, solve climate change. But here's the counterargument that nobody talks about. Earth has an expiration date. Not next year, but eventually. The Sun will become a red giant in about 5 billion years, engulfing Earth entirely. And before that, in roughly 1 billion years, the Sun's increasing luminosity will make Earth uninhabitable. Humanity becoming interstellar isn't just about curiosity, it's about survival. In 2022, NASA achieved something remarkable with the James Webb Space Telescope. It's now detecting the atmospheric composition of exoplanets, planets orbiting other stars. As of 2024, we've confirmed over 5,600 exoplanets, and scientists estimate there are at least 100 billion planets in our galaxy alone. Many exist in the habitable zone, where liquid water could exist. We're not just blindly shooting into space anymore. We're identifying potential destinations. But let's address the elephant in the room, the speed of light barrier. Einstein's theory of relativity tells us nothing with mass can reach light speed. At 99.9999% light speed, you'd need infinite energy. Chemical rockets, which got us to the moon, max out around 0.006% light speed. Ion drives, currently used on some spacecraft, reach about 0.01%. Even theoretical fusion rockets might reach 3 to 5% light speed. We need something revolutionary, and scientists are exploring concepts that sound like science fiction but are rooted in actual physics. The Alcubierre drive, proposed in 1994 by physicist Miguel Alcubierre, suggests warping spacetime itself, creating a bubble that moves faster than light without actually breaking Einstein's rules. You're not moving through space, you're moving space around you. Recent 2021 research by physicist Eric Lentz proposed a modification requiring less exotic matter, making it slightly more feasible. Still theoretical, still requiring energy equivalent to the mass energy of Jupiter, but no longer completely impossible. Then there's the concept of generation ships. Stanford physicist Gerard O'Neill designed massive rotating cylinders in the 1970s that could house thousands of people with artificial gravity. The idea: send a self-sustaining population on a journey lasting multiple human lifetimes. Their descendants would reach the destination. A 2018 study calculated we'd need a minimum population of 98 people to avoid genetic bottlenecks on a multi-generational journey, though realistically thousands would be safer. Here's something that happened just in 2023. China announced plans for a long-term space station and asteroid mining operations, with explicit goals of supporting deep space exploration. The private sector is exploding too. Companies like SpaceX are dramatically reducing launch costs, from $65,000 per kilogram on the Space Shuttle to around $1,500 per kilogram on Falcon 9. This economic shift makes ambitious projects increasingly feasible. But will humanity actually do it? History suggests yes. We're an exploring species. We walked out of Africa with primitive tools. We crossed oceans on wooden boats without knowing what was on the other side. We went to the moon just 66 years after the first airplane flight. The International Space Station, launched in 1998, has been continuously inhabited for over 23 years, proving humans can live long-term in space. The question isn't if, but when and how. Will it be autonomous probes sending back data? Will it be human crews in cryosleep? Will it be AI-guided ships carrying human DNA to seed new worlds? The technology is emerging, the targets are identified, and the motivation, whether survival or curiosity, is hardwired into us. So here's what I want to know from you. If you could board a one-way mission to a planet orbiting another star, knowing you'd never return to Earth, but would be part of humanity's greatest adventure, would you go? Make sure to follow for more mind-expanding space content that challenges everything you thought you knew about our universe.